Okay, hello class. So let's start our lesson today. Uh, our today's topic will be are the segment subsystem. It's one of the major subsystem in satellite communication system. As we have discussed earlier, satellite communication system has two major subsystems. One in the orbit, we call it the space segment. The other in the ground, we call it Earth segment. You can call it Earth station also. So our today's topic will be, we have discussed the space segment previously, so today we'll see the Earth station or subsystem called Earth segment. So how we define the Earth station or Earth segment of a satellite communication system. So any transmitting, this is a transmitting system which sends information or signal to the satellite. Okay, the information can be voice, audio, video, data, or a combination of this, modulated on a carrier and transmitted to the satellite, or any system which receives information from the satellite. We call it Earth station. So any system which transmits and receive information to or from the satellite, we define at Earth station. So this slide, you can see we have Earth station here. We call it uplink station or transmitting Earth station, which sends our information to the satellite. That's one station. So satellite communication has two Earth stations. One station, on the other hand, which is designed, configured to receive information from the satellite. So we call it receiving downlink center, downlink station, receiving Earth station. You can call it this name. So that's how Earth stations is defined. So the Earth segment of satellite communication systems, as we have discussed, mainly consists of two Earth stations. One for transmitting purpose, one receiving purpose, two Earth stations. So this is transmitting Earth station, ES. This one is receiving Earth station. Okay. So these two, the transmitting and receiving Earth station, these two we call them the Earth. We call them Earth segment subsystem. Okay. Now the configuration or design of these Earth stations depends on many factors. So all Earth stations are not the same. The configuration design of all Earth stations are not the same. First, it depends on location. Where you want to put these Earth stations on the ground, which communicate with the space segment, the location itself determines the configuration. The type of the Earth station first depends on location. It is used for fixed satellite service. Is it using for mobile satellite service? Is it used for broadcast satellite service? The location and the service determines the type of configuration of the Earth station. That's one important factor, location. But in addition to the location, the design and configuration of Earth stations also depends on many factors, as you can see on the slide. Now, what type of, how much transmitted power, uplink, downlink frequency, what type of antenna, gain, efficiency of our antenna, noise figure, figure of merit, all these factors you have to take into consideration when we design earth station. Okay, when we design earth stations, because the design of earth station depends on these main factors. So when we discuss earth station, it is here general. We'll discuss the general configuration. But the specifically, when you design earth station for fixed satellite service, for broadcast satellite service, so you have to consider the parameters listed here, all the parameters. But generally, earth station looks like this. So when we say earth station, it can be this case, this earth station is used to transmit and receive simultaneously. So in this case, we have earth station which is maybe designed only for transmission. It will not receive. This earth station may be designed only for receiving earth station. But in many cases, earth station can transmit and receive simultaneously. Okay, we can use one earth station for transmitting and receiving information from the satellites. So this case, the satellite earth station has 4 subsystems. So the first subsystem, so you can write here, subsystems of earth station. The first is the transmitter subsystem. So first subsystem for earth station is the transmitter. So the transmitter part, as we have seen here in this block diagram, the first subsystem is the transmitter. This transmitter part, that's the first subsystem. We'll discuss each one by one. Second subsystem is the receiver part. So receiver is another subsystem for earth station. On this side, all this circuitry here is one earth, the receiver subsystem of the earth station. So receiver subsystem we'll discuss one by one. Third one is the antenna subsystem. And finally, we have tracking equipment subsystem. So there are basically 4 subsystems for satellite earth station. Tracking equipment. Okay, so in some books they make it 5, including the power supply unit, but for let's consider 4 subsystems: the transmitter subsystem, receiver subsystem, antenna subsystem, and tracking equipment. All these are subsystems components of earth station. Okay, so let's start from the transmitter earth station. So transmitter, the signal may be analog or digital, it doesn't matter. Now let's consider digital transmission. of audio, video, or data. So this data comes from the network on the ground. We have terrestrial network on the ground, what we call it mobile or mobile communication network. Other terrestrial networks, we have here baseband equipment. We call it BBE. Okay. So as you can see here, from the baseband equipment, the digital data comes to the encoder part. This is our encoder transmitter. We are discussing now the transmitter section, transmitter subsystem of satellite earth station. Okay, so the encoder, first the digital info enters into the baseband equipment from where? From the terrestrial network. From any network on the ground, the data comes to the baseband equipment. I'll show you in the video this equipment. So that's the first step. Next, we have what? We have a device called encoder here. That's part of the transmitter. Then the encoder adds additional bits for error detection and correction. Before transmitting your data, the data comes here from terrestrial network to the BBE baseband equipment. Then this data goes to the encoder part, which add additional redundant bits for error detection and correction. After that, we have a modulator. As you know, this digital data modulated on carrier frequency. In this case, it is high frequency of 70 megahertz. Okay, the data is modulated on intermediate frequency of 70 megahertz. It depends on the satellite transponder bandwidths. In some cases, if the satellite transponder 36 megahertz, the high frequency is 70 megahertz, most of the cases. But in some satellites, the transponder what we have discussed in space segment, some transponders, they have bandwidths of 72. In this case, the high frequency, the carrier frequency, will be 140 megahertz, but mostly it's 70 megahertz IF. So this is our IF frequency. After what? After encoding, then modulation. Now our digital data is modulated on a carrier frequency of 70 megahertz. Now this frequency, 70 megahertz, is very small frequency. To transmit in satellite for long distance, we need to step up this frequency into high frequency. So the next device you will see is up converter mixer. We have discussed these devices previously, right, in microwave course and so on. So this up converter mixer, we have here local oscillator frequency, and this is the intermediate frequency. So the output will be here. The summation, the radio frequency FRF will be the summation of FIF intermediate frequency plus the local oscillator frequency, right? Because it's up converter mixer, which convert the 70 megahertz. How much is our uplink frequency here? For satellite, it can be C-band, let's say 6 gigahertz. 6 gigahertz is our uplink frequency, right? So this up converter mixer translates this 70 megahertz into 6 gigahertz by using this up converter mixer. Now, why we need to increase the 70 megahertz into 60 gigahertz? Because satellites are very far distance. If you take geostationary satellite, they are 36,000 kilometers. So we need high frequency. High frequency means high energy. So only high frequency signals can transmit all the way to the orbit. So this 70 megahertz is very small frequency. So we need to increase it to 6 gigahertz by a device called up converter mixer. Okay. So it's also part of what? It's also part of the transmitter. Next, the next device in the transmitter subsystem is so here up converter for conversion of modulated signal to what? To higher frequency we have discussed. Finally, this modulated high frequency signal. Modulated means we have a carrier signal, modulated or digital data, and it is converted into high frequency. Now it's 6 gigahertz frequency carrier up converted it from 70 megahertz to 6 gigahertz by a mixer. Then this modulated high frequency signal must be amplified to high power using what? High power amplifiers like Klystron amplifier, this device, high power amplifier tubes. You can find Klystron, you can find traveling wave tube, you can find cross-field amplifier, CFA. Okay, previously magnetron also used, but nowadays this type of amplifiers, high power amplifiers, are used. Then now here we have high frequency, high power modulated signal, which will be converted into electromagnetic radiation by the antenna system and transmitted to the orbit. That is the transmitter subsystem of the earth station. Okay. The first part, the transmitter section here. So earth station, how many subsystems? We have discussed 4 subsystems. So we have seen now the first one, the transmitter. Next, the subsystem for earth station is the receiver part. Okay. So here, on the receiver part, the earth station antenna receives the downlink signal. So we have said we transmit how much? 6 gigahertz uplink, right? Now the antenna receives downlink 4 gigahertz. As I said, always downlink frequency is less than uplink frequency. So 4 gigahertz comes from the satellite. Next we have what? A device, what we have discussed before, which is also exists in the space segment, low noise amplifier. This amplifier provides very high gain, very high gain. What's the characteristics of low noise amplifier? High gain, but it generates very small amount of noise. Last time I showed you low noise amplifier with gain of 60 dB. Typical low noise amplifier we use in our satellite TVs. You can buy this low noise amplifier around $8. Gain 60 dB, high gain, and noise generated by this device is only 0.6 dB. Okay, but when signal comes from the satellite side, our signal plus there will be what? There will be noise, right? This low noise amplifier increases both the signal and increases both noise, which comes from the antenna side. But when it amplifies the signal by 60 dB, it amplifies the noise also by 60 dB, but the amplifier itself generates only 0.6 dB noise. It does not generate too much noise. That's why we call it low noise amplifier. So how much gigahertz? The downlink 4 gigahertz, right? This 4 gigahertz first amplified by the low noise amplifier. Then here we have another mixer called down converter mixer. Now the incoming carrier frequency is 4 gigahertz, which will be very difficult for demodulation. This high frequency is difficult for what? Processing. This signal contains our information. To get our information, we need to demodulate, remove the carrier. We need to identify errors and correct these bit errors by using what? Here, encoder, the reverse will be decoded. Here we add error correction mechanisms. Then this decoder is used for what? To detect not only detect and correct errors, right? Bit errors. But before that, we have also what? The opposite of a modulator. Here we modulate our bits, our digital data into 70 megahertz carrier. Now we need to modulate it. So you see, before demodulation, before decoding, we have to reduce this high frequency carrier, 4 gigahertz, into 70 megahertz. But here on the transmitter side, increase it from 70 megahertz to 60 gigahertz. We need to increase the frequency. Why? Because during transmission, we need high energy, high frequency. But on the opposite, in receiver circuits, very difficult to demodulate, to decode this 4 gigahertz carrier. So before demodulation, before decoding, in generally, before DSP, what we have discussed in our course, digital signal processing. Before processing, this carrier must be down converted into only 70 megahertz IF by mixing it with local oscillator here. So in the transmitter side, up converter mixer, on the receiver side, down converter mixer. Why we need to down convert it? Because here RF signal which comes from the antenna, now it is down converted into IF, which means the 4 gigahertz downlink signal down converted into 70 megahertz IF signal. This is called intermediate frequency. This is called RF, right? This is our RF. This after mixing we call it IF, intermediate frequency. How we get it? By using a device called up-down converter mixer, which is used another oscillator called local oscillator. So now after the frequency is down converted to 70 megahertz, then it is easy for what? Easy for our decoder, which is the opposite of encoder. Encoder on the transmitter side, which add additional bits for which helps us for error detection and correction. So after decoding, we produce what? We produce error-free by removing error correction bits. Where this error correction bits added in the encoder side. The encoder adds some bits. These bits, additional bits, are used for error detection and correction purpose. Now on the decoder side, by using this error correction detection correction bits, it generates error-free binary information. It can be video, audio, or combination, as we have said. Then this binary information given to what? Given to the baseband equipment. After decoding, it goes to the baseband equipment and go to the terrestrial network where the users access this information. So that is the receiver subsystem we have discussed. So we have discussed the second subsystem, which is receiver. Next, we are not discussed the antenna part. So let's see the tracking equipment. So on the tracking equipment, because the antenna subsystem we have discussed previously, you can go through this slide. The antennas used in satellite communication, the horn antenna, the reflector antenna, antenna arrays we have discussed previously. So we go through this antenna subsystem. Another subsystem for satellite earth station is the tracking subsystem. So this tracking subsystem has two main functions. So this video, I'm sharing a video with you. The installation of earth station for Ku-band 7.3 meter VSAT. This is the reflector antenna they are installing. So when you say earth station, how many subsystems? 4 subsystems. So here is the first subsystem, which is the antenna part. Next, you will see the tracking equipment. I will show you that. This is a antenna subsystem still. Okay, now you will see the resolvers, the installation of the tracking equipment. Before we come to the indoor, this is outdoor equipment. The antenna must be positioned properly toward the satellite. As we have discussed, satellites are rotating around the Earth. So there must be synchronization between the Earth station antenna and the antenna on the space segment. Okay, so there must be a tracking equipment on the ground. Its first function, data acquisition. Its first function is so as you can see here, this tracking subsystem has 2 functions. First, satellite acquisition, which means collect information from the satellite. Let's see the block diagram. So here we have the tracking equipment. So based on the amount of signal power we receive, the amount of power we receive from the satellite from the antenna, we receive the downlink frequency signal comes amplified. You see, some part of portion of this signal goes to the tracking equipment. It's just like a sensor. It senses the signal power receiving. If this signal power goes down, it decreases, which means there must be adjustment between what? Between the antenna on the ground must be adjusted its position, moving it up, down, or left to right. Adjustment of the antenna must be performed by what? By the this tracking equipment. It continuously sense the signal power. If there is some power reduction, the tracking equipment, as you can see here, this wire goes to what? For the antenna in order to control the satellite. Okay? Sorry, in order to control the antenna position. That is the tracking equipment. Okay?